Good afternoon everyone. I am Dr. Kusumita Kundu, Assistant Professor of Chemistry in SBIST. Now, in the last class, we have discussed about the Lambert-Weier's law, absorbance and transmittance. In today's class, we will be discussing about the electronic transition. Now, before that, we need to know that how many types of electronic levels are there. Okay. So, in any organic molecules, there are basically 5 types of electronic energy levels. That is sigma, sigma star, pi, pi star, and this n. Okay. Now, if there is only sigma electrons, then the available electronic levels will be sigma and sigma star. If there is any pi electrons, then the available electronic levels will be sigma, sigma star, pi and pi star. And if there is any non-bonding electron, that means the lone pair of electrons, there will be another electronic levels, that is n. Okay, so these are the available electronic levels. Now, if we want to know about the transition between these levels, what we have to know about the selection rules. Okay, there are basically 2 types of selection rules. 2 types of selection rules. First one is spin selection rules. Okay, first one is spin selection rule. Now, according to the spin selection rule, the transition can happen between singlet to singlet. The transition can happen between singlet to singlet. Singlet to triplet transition, singlet to triplet transition is spin forbidden transition. This is not spin allowed transition. Only singlet to singlet transition is spin allowed transition according to the spin selection rule. And the second type of selection rules are symmetry selection rules. Okay, symmetry selection rules. Now, as per the symmetry selection rules, the transition can happen between the same symmetric electronic levels. Okay, so transition can happen between sigma to sigma star, pi to pi star. So these 2 transitions are symmetry allowed transition. But in sigma star or in pi star, these 2 transitions are symmetry forbidden transition. Okay, these 2 transitions are symmetry forbidden transition. These 2 transitions are symmetry forbidden transitions. But in reality, we can see these 2 types of transition, but they are very weak and the intensity of these 2 transitions are very low. Okay. So now we will be drawing the energy diagram. Okay. So sigma has the lowest energy. This is the energy diagram. Sigma has the lowest energy. Then we will have pi. Then it is for n, that means non-bonding electronic levels. It is pi star, and this is sigma star. Okay. So based on the 2 selection rules, the possible transition will be sigma to sigma star, pi to pi star, n to sigma star, and n to pi star. Okay. So the possible transition will be sigma to sigma star, n to sigma star, pi to pi star, and n to pi star. These are the possible transitions. These are the possible transitions. Now, if we want to know the energy order of this transition, from this energy diagram we can say that sigma sigma star will require the highest amount of energy. So, if we write the energy order of this transition, so the order will come as sigma sigma star requires highest amount of energy, then n sigma star, then pi pi star, then n pi star. So this will be the energy order of the electronic transition. And what will be the wavelength order? Wavelength order would be just opposite to the energy order. Okay. So this will be the wavelength order would be n pi star greater than pi star greater than n sigma star greater than sigma star. Okay. So this is the energy order for electronic transition. This is the wavelength order for electronic transitions. Okay. So the next part we will be covering in the next video. Thank you so much.